everyone! Today we're diving into how end mills work. Let's get started. Welcome to WEIX Tools, your go-to source for all things cutting tools. Click the link below this video to get your free WEIX Tools product catalog. And don't forget to subscribe and hit the bell icon for more practical tips. CNC milling is a versatile machining process known for precision and complex parts. It involves different techniques, operations, and can accommodate diverse tooling. End milling is one of them. In fact, this is the second most popular machining technique after CNC turning. Different tooling options, high material removal rate, precise finish, and some other factors make this process widely used across industries. This article will elaborate on what is end milling, compatible cutters, applications, benefits, potential challenges, and machining considerations. What is end milling? Like every other subtractive manufacturing process, end milling involves the use of rotating cutters with multiple edges to remove material until desired shapes and features are formed. It crafts complex and intricate features on metals, alloys, plastics, composites, and other engineering materials. What makes end mills different from other tools is the helical design of cutting edges. The cylindrical shaped shank contains tooths on both ends and sides, so they cut the pieces from work multiple directions. Moreover, a variety of CNC end mills square, ball, nose, corner, radius, etc. allow you to work with multi-features 3D shapes. With the right cutters, you can make complex contours, deep holes, pockets, slots, flat profiles, recesses, etc. Anatomy and terminologies. Before moving into further discussion, let's look at its anatomy and key terminologies. Shank, the cylindrical part of the mill that is clamped into the machine spindle or tool holder. Neck, the reduced diameter section between the shanks and the cutting portion for deeper reach and clearance. Flute, the helical grooves along the end mill's body, which forms during cutting. Edge, machining, cutting diameter at the widest point of the edges. Cutter sweep, the arc or path formed by the cutting edge during rotation. Cutting length, the axial length over which the cutting tooth's edges engage in material removal during milling. Helix angle, the angle between the end mills, helical flute, and its center line. How end mills work. A specialized end milling machine or regular CNC machine accommodates suitable end milling tools in its spindle or other rotating components. Then, it controls the movement precisely across the workpiece in APR. Determine tool path, the size of the cut, depth, speed, cycle time, and all other variables depend on CNC inputs and geometry and end mill sizes. The detailed steps for how the end mill works. Part design and programming. A detailed design of the part to be end milled is created first, outlining all features, dimensions, and machining directions. While creating the design, it is essential to consider the capabilities of end milling cutters, what kind of shapes they can machine. Machine setup. The end milling cutter is secured in the spindle scollet or tool holder, whereas the vice clamps or fixtures hold the workpiece. Consequently, the position of the working pieces is parallel to the table or the spindle axis. The value of the input parameters depends on the working materials and tools. Coatings, the operator sets the reference point. Work offset after setting tools and work milling process. Once the program is running, the spindle rotates the end mill tool, and then the cutting edges interact with the material and form the chips via shearing. Edges at the end performs axial cutting and side edges perform radial cutting, whereas helical flute design facilitates easy chip removal. The entering angle and cutting path depends on the CNC program. The same program codes dictate the spindle to move The cutter across the axis XYZ.